Hey guys, welcome back to another episode in the Spring series. In this episode I'm going to show you how to do dependency injection and inversion of control without Spring. So one of the biggest features of the core Spring module is dependency injection and inversion of control, which are very similar things. But what I want to do today is show you how to do dependency injection without the use of the Spring framework, so that you can understand what Spring is going to do for you before you actually use it, right? Because it doesn't make sense to really jump into something if you don't really understand it in the first place. So I thought I might, just give you a brief introduction into what dependency injection is, and then we can see how Spring is going to make it so much easier for us when we develop applications. I made a short presentation here so you can see what we're about to learn before you learn it, so you understand some of the core concepts. So dependency injection and inversion of control without Spring. Okay, so here's a first little diagram here that we can use to understand what a dependency in a client is. There's different names for it, but you'll see dependency often. So let's say that you have a class called vehicle, and that class has an engine object within it as one of its fields. That means that vehicle depends on an engine to do what it needs to do. So the client in this case would be vehicle, and the dependency would be engine, because a vehicle depends on an engine to do what a vehicle needs to do. So that's as simple as I can explain it, right? So it's just a class that depends on another class to function. And so the dependency in this case would be the engine, and the vehicle I'm going to call client, but there's different names for this, but client is the one that I prefer, so I'm going to call it client. So you have a client that depends on something. In this case it's an engine. And so a more realistic example that you might see when we start getting into more Spring development is you have a service, and a service is simply a class that performs a set function. It does something specific. In this case we have a library service, so we can imagine that the library service does something like managing books and gives books to people, or anything like that. It can do any function that we want it to do. But the point is that library service is a client because it depends on a book repository service. So it depends on this book repository class to obtain books from the database, find books, delete books, update books. That's basically the interface, or the system we'll be using to get books from the database and update books and all that stuff. So our library service needs the book repository to function, so it's a dependent relationship. So the library service depends on the book repository. So that's all you need to know. That's what a dependency is in terms of dependencies. So with that in mind, we can now look at what dependency injection is and inversion of control. So you're going to see some examples in a second of what you would normally do without dependency injection, and then I'm going to explain to you how to do dependency injection yourself without the Spring framework. But dependency injection, as a simple way of explaining it, is where you instantiate the dependency of a client class outside of the class and then inject the dependency into the class. So one way that you can inject a dependency into a client class that needs a dependency to function is you can pass it by the constructor, or you can pass it by a setter method. So what this does is it provides a loose coupling, which is a term you might see when looking into dependency injection. And when you don't use dependency injection, when you just instantiate so this is what you would normally do without dependency injection. This is something you might see and you might have done many times. You have a class that depends on, let's say vehicle depends on engine. This usually means that you're going to create the engine object in the constructor of vehicle or something like that. So that's what you call tight coupling. The vehicle depends on the engine, but it's tightly coupled because to create the vehicle, you also need to create the engine, and the vehicle needs to manage the engine object and instantiate it and all that stuff. So they're tightly coupled, so it makes things a little bit tricky. So what you want to achieve is loose coupling, where it provides some modularity, separation of concerns. They're not so interdependent on each other. You can do things like easier unit testing of the dependencies, so you can test them easier using a testing framework. And then you can also do easy swappability of dependency implementation. So let's go down here. So let's say that our library service depends on a book repository, but there's different ways of storing and retrieving books. In this case, let's say that this book repository is an interface, but the object provided to library service is a MySQL book repository implementation. But you can easily swap that out to something like a file book repository where it stores everything in a file instead. So it's kind of a tricky thing to understand when you're not actually coding it and seeing it for yourself. But you'll see that when we do dependency injection and inversion of control, that we're able to easily swap out the dependencies, the implementations of the dependencies, because we'll code to an interface. But in short, the thing that you really need to understand is that dependency injection is all really just injecting the dependency into your class using some outside method. And that provides too many different benefits that I just explained below. So loose coupling, modularity, separation of concerns, easier unit testing, and easy swappability, all things that we will see in our applications when we start using dependency injection. So then we get inversion of control, which is a lot of the times used interchangeably, but dependency injection often is used with inversion of control. So inversion of control means that you're giving control of the dependency and object instantiation to an outside system. So in this case, without dependency injection, what we're doing is, like I said, we're initializing the engine class inside of the vehicle. So it's not being passed in by any constructor method. It's not being passed in by a setter method. It's just being created inside the vehicle constructor. So in this case, it's tightly coupled. But if we give the control of the engine instantiation to an outside system, you're inverting the control of that to something else. So the engine or the vehicle no longer has to worry about that. You're taking the control of the engine away from the vehicle and giving it to something else. And that provides all these benefits that I just explained here. So like I say here, in the case of dependency injection, create the dependency objects outside of the client class and then pass them in by methods such as constructor injection. So this is a big feature of the Spring Framework core module. What you're going to do is give you're going to mark things as beans, which are really just your dependencies, and the Spring Framework will take the responsibility of initializing these dependency objects and then passing them in, injecting them in to the client classes that require them. So that's very powerful, and we're going to see that in the next episode. But for now, let's jump into IntelliJ and see how we can use dependency injection on the most basic level. And we're going to make a new Java project, not a Spring project, because like I said, we're going to see dependency injection without Spring so that we can see next episode how we can use Spring to make it even better. So Java 16, doesn't really matter the version. And we'll call this dependency injection without Spring. And I'm going to move this to my tutorials folder. There we go. Finish, create, new window. Okie dokie, let's open everything up and get set up here. So we're going to make a new service class. So like I told you before, don't really get too worked up about, not knowing what a service is. It's really simple. A service is simply a class that performs a defined function within the business logic of your application. So what do I mean by business logic? Business logic is simply the code that makes your application function. It just does stuff. It's just their code. But yeah, a service is simply a class that performs a defined function. In this case, we want to create a restaurant service. Restaurant service. I hope I spelled restaurant correctly. This will be a class. So as you can imagine, this is going to be a service for restaurant stuff. And that can be anything. But so what do we want our restaurant service to do? Let's say that we want our restaurant service to process orders. Let's say that we get an order from like a service, an app such as DoorDash or Uber Eats, and we need to process the order so that our cooks can cook it for us. So public void process order. And we're going to keep it really simple. This is not an episode on how to do restaurants, but we're going to show how to do dependency injection. So new order started. Okay. And now we need a dependency that we're going to put inside of this. We're not going to do dependency injection yet. I'm going to show you how you would do it the regular way, and then I'll show you how you can do a very basic dependency injection. So what is our restaurant service going to depend on? Let's say that we depend on a food service or a kitchen service. We'll call it kitchen service. So new Java class kitchen service. Why? Because our restaurant depends on the kitchen to create the food. So we're going to have a public class kitchen service. And what is our kitchen service going to do? It's just going to have a method called cook food. So public void cook food. All right, and we'll say it's like sizzling, cooking food. There we go. So now we can go back to our restaurant service now that we have this kitchen service and put it as a dependency within the restaurant service. So we're going to do, this is our dependency because our restaurant service depends on it. So private kitchen service, kitchen. Oh, I spelled kitchen. That's embarrassing. I spelled kitchen incorrectly. Kitchen service. That's sad. There we go. So kitchen service. So how do we initialize this kitchen service within our class here? One way we could do that, we could do it up here if we want to. So is equal to new kitchen service. That's one way you could do it. Nothing wrong with that. But we're just going to do it in the constructor. So public restaurant service constructor. So this dot kitchen service is equal to new kitchen service. So what we have done here is pretty simple. All we've done is given this restaurant service the responsibility of initializing and handling this kitchen service object. So in this case, they would be referred to as tightly coupled, since the restaurant service has to do all of this here. So from a design perspective, this would be a very bad idea because you don't want tight coupling usually. You want to have them loosely coupled so that you have the benefits of loose coupling. So some of the benefits are why this is such a bad idea to do it like this. I mean, you can do it like this, but just from a design perspective, it's not a good idea. So it's hard to do testing on this dependency here because it's created inside of this restaurant service class. It doesn't live outside of the restaurant service class or object when you initialize it. So there's no really easy way to test this kitchen service if you're going to do some sort of unit testing or anything like that. So that's one thing. Also, there's poor separation of concerns. Usually you want to separate everything into different modules. So having the kitchen service created somewhere else and managed by a different system would probably be a good idea. And then you could pass it in, as I'm going to show in a second, with injection. So let me try and define what is loose coupling. Loose coupling is simply, it means that a change in the dependency does not require a change in the client. So because this is such a simple example, this doesn't really play out that well. Like if I just change any of the code in kitchen service, it's not really going to affect our application that much, or this restaurant service that much. But in a more complex application, if we were to change the kitchen service in any way, it may affect our restaurant service. But let's say we change it in a way such as this. Let's say that we rename kitchen service to something else. Let's say that we name it without refactoring the rest of the code here. So refactor. And it still refactored it anyway. But let's say that we kept it as kitchen service. So in this case, it no longer works because kitchen service is no longer called kitchen service anymore. So we have to go into restaurant service and change our code. And as if you can imagine, this is a bigger file, a bigger class file with more code. This would be more problematic because we would then have to change everything to match it. A very basic example, like I said, but that's one example. So in a more realistic scenario, you might want to code to an interface. So instead of having a class here, you would have an interface, and then you could swap it easily with any implementation that you want to provide, in this case, a kitchen service. And we'll see that in a second, and especially when we get into a Spring framework. It'll allow us to do swappability really easily with our classes. Also, one downside of not coding to an interface where you can swap it out for any different implementation is that if you want to have, let's say that you give your restaurant service to someone else, but they don't want to use a kitchen service, they want to use some other type of service that cooks their meals, then they cannot, use your restaurant service. They can't pass in their own type of service that they want to use. They have to use your kitchen service. And then therefore they might just even create their own restaurant service. So as you can see, it's just because it's not swappable, you're stuck with this concrete implementation of kitchen service that you have to, instantiate within the restaurant service class. And it just makes it a pain to change everything around. And, it makes it less dynamic. It's more static in the way that it works. So hopefully that makes a little bit of sense. I know this might be a little confusing just because you haven't seen like a concrete example yet. So once you get more into the Spring framework and what I'm going to be teaching you in this tutorial, you're going to see more examples of why this is a better idea to do it how I'm trying to explain to you to do it. So not like this is what I'm saying. So in short, if you didn't understand a single thing I said, basically you don't want to do it like this because you want less interdependency. You don't want the restaurant service to depend on the kitchen service so concretely. You don't want it to create its own you don't want it to have to create its own object of kitchen service. You want to try injecting the kitchen service into restaurant service using dependency injection. And now let me show you how you can do manual dependency injection to achieve that. So let me first rename this back to kitchen service. So refactor kitchen service. All right. So what I'm about to show you is a very, very, very basic example of dependency injection. We're not using any, inversion of control framework like Spring to help us out. We're just going to do it manually. So first what we want to do is, obviously we do not want to instantiate the kitchen service within our restaurant service. So we're going to get rid of that. Instead, we're just going to pass it in. So kitchen service is equal to new kitchen service that you pass in. So already you have made it less coupled. It's loosely coupled now because you're passing it in from an outside source. So now wherever we declare a new restaurant service, we can then also pass in the kitchen service. So let's go back to our main here and let's see how we can do that. So we're going to do restaurant service. Restaurant service is equal to new restaurant service. And as you know, the parameter is going to be a kitchen service. So in this case, we can do kitchen service. Kitchen service is equal to new kitchen service. And then you're going to pass in the kitchen service. So that's as simple as it is. This is a manual dependency injection, also known as constructor dependency injection. So now we can go ahead and do restaurant service dot process order, which should call the dependency method as well. So we should see cooking food. There we go. Oh no, it says new order started. Let's go back here. Okay, yeah, we forgot to call the kitchen service method. So kitchen service dot cook food. So now we should see cooking food. There we go. So now the client class of restaurant service is calling upon this dependency to do something, which in this case is cooking the food. That's a very basic example. So now we've achieved dependency injection using a constructor, but in a more realistic scenario, you're going to be doing a lot more. So in a realistic scenario, you're going to be giving control of instantiation here. You're not going to be doing it yourself. You're going to invert that control to a framework like Spring, for example. So Spring will find the kitchen service dependency class, and then it'll instantiate it for you when the program starts up, and then it'll pass that kitchen service automatically into your restaurant service. So you don't even have to worry about any of that. The control is inverted from you and your program to Spring. So Spring will do all the work for you. So that's just literally what inversion of control is. You're taking the control away from the restaurant service to have to create its own kitchen service and then giving it to your main method. In this case, then with Spring, we're going to give control. We're inverting the control from our main method to Spring framework. So we're just abstracting our code even more, making it more simple to use, making it more modular, loose coupling, all those cool things in terms of design. So hopefully you see the core concept here. What is injection? Simply injecting this kitchen service object into your restaurant service whenever the restaurant service is needing it. So again, just to reiterate, instead of the restaurant service creating its own kitchen service, it's being injected, okay? That's all injection is. That's the most simple way to explain it. And there's different types of injection, like I said. You don't have to pass it by constructor. You can do other types of injection, which we'll see later on. So now let me give you another example of how you can do this and also show you how you can introduce some swappability into this. So let's say that we have a texting service, a service for texting. Okie dokie. So this texting service will depend on another service. We'll call it our messaging service or message service. But in this case, instead of doing a concrete class for our message service, we're going to code to an interface. So interface message service. So why are we doing this? This is because let's say that we want different implementations of message service. We don't want one way to do messaging. We can have different implementations of message service, and then that means that our texting service doesn't have to depend on one single implementation dependency. It can use any of the message service types or implementations to do its function. It doesn't have to even worry about that. So we're going to make a contract here, and our contract will be string get message. So this is simply an interface that has a single method get message that returns a string, which is a message. So now what we have to do is, well, first of all, before we do this, we're going to go to our texting service and tell it the dependency. So private message service, message service. So even though message service is an interface, not a concrete class, we can still tell it that that's the field type, so that this variable here can be any type of message service, any subclass, or any class that implements the message service interface. So it's swappable out with implementations, and you'll see that more in a second. So we're going to create a new Java class, and this will be an interface, and we're going to call this the English message service implementation. So IMPL. That's just a short way to say that. So English message service impl for implementation. Click enter, and then we're going to implements. Oh wait, we don't want an interface. I'm silly. So we want a class. And there we go. So that's going to implement message service. And then now we have to implement the method provided by message service. And we're just going to give it a message. So return, hello, my name is Cody. So now we can go to, So now we can create another service. Let's say that we don't only want an English message service, we also want a Spanish message service in case we're talking to Spanish people, our texting service. So we can create a new Java class, Spanish message service implementation, or impl. So this will also implement message service, and go ahead and implement the get message method. And this time we'll say it in Spanish. So hola, me llamo Cody. Me llamo Cody. All right. So now we can go to our texting service, and we can choose whatever implementation we want to provide. So let's go to our make a constructor for this. So public texting service. And we're going to provide a message service as its parameter. And so this dot message service is equal to message service. And we're going to make a method here within our texting service to test this dependency out. So public void text back. How about respond to text? So we'll do this dot message service dot get message. So again, even though this is an interface, we can still use it as our type here, and we can call the get message method, and then it'll call that method. It'll call that method on whatever object type we're passing in, either the English message service or the Spanish message service. So it's swappable. We can provide any single one because the type isn't anything specific. It's the generalized message service interface. So now what we have to do is inject that message service implementation into our texting service. So let's go to our main here and do that. So texting service is equal to new texting service, and we need to now provide a service to implement. So we're going to do, let's say we want to do Spanish first. So Spanish message service implementation, Spanish message service is equal to new Spanish message service implementation, and now we can pass that in. So we're injecting the Spanish message service as the dependency for texting service. So then we can do texting service dot respond to text, and that should call the get message method of the Spanish message service. So let's run this and see what we get. Nope, we didn't get anything, so we messed up. Okay, so I see the problem. We kind of messed up here. So all we're doing is doing this dot message service dot get message. That doesn't print anything, so it only returns a message, right? See, it only returns one, so we can then print it out. So s out this dot message service dot get message. Get rid of that extra semicolon. Now run this, and it should say it. So hola, me llamo Cody. So there we go. We have injected a specific implementation that we have chosen into our texting service. So that's what I mean by swappability. You don't have to provide a concrete implementation or a concrete class type inside of your texting service. You can choose what implementation of the message service you want before you make the texting service, and then provide it dynamically into the constructor. So you're injecting it, dependency injecting using constructors. Now, so what is Spring going to do for us to make this even better? So like I said, it's automatically going to create our dependencies here and then inject them into our texting service. But also, we can add configuration. So we can tell it before we even run the program which service that we prefer, and then it'll know which one to create for us and then inject into our texting service. So later on, we're gonna be able to create things called profiles, which allow us to set a profile in a config file, and then Spring will look at that config file, and then from that, it will know which service implementation to provide into as a dependency into our service that we're injecting it into. So yeah, that's basically all I want to show you. Hopefully that makes a lot of sense. I know it was a little confusing. Dependency injection and inversion of control is a really hard topic to understand for beginners. It was very hard for me to understand, but hopefully this explanation was good. I tried to do it step by step for you guys and explain what it means. So now that you hopefully understand dependency injection and inversion of control, what those two concepts mean, we're going to, in the next episode, dive into using inversion of control using Spring, and then we'll see how we can use dependency injection using Spring. So stay tuned for that. If you have any questions about this episode or need help, you can hop into our Discord server. There will be a link for that in the description below, so you can ask for help there. Get some friends, whatever you want to do, just join it. And it's a big community for programmers. I'm enthusiastic about coding and stuff like that. Another thing is I'll leave resources for what I taught you this episode. So I'll leave some books and resources on dependency injection in the description below, so you can check those out if you want some supplemental material. I'll also leave a link to the code for this episode so you can see the code and come back to it at any point. I'll write it up with comments and everything like that, so it's explained in written detail, and you can bookmark that if you want to and come back to it, like I said. So that'll be in the description as well. And then the final thing is, if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, and you get some cool perks like early access to all of my new videos. You get a cool rank on my Discord server, so you can show everyone how swaggy you are. And also you get to see yourself on the screen like you see right now. So thanks to everyone who has joined as a member. If you want to join as a member to support this channel, feel free to do so. If you can't, then that's okay too. Thanks for watching this video anyway. I really appreciate it. Alright, so that's it. If you like this video, leave a like. If you want to see more, subscribe. And peace.